Okay, in this video, we're going to be deriving some projectile motion formulas using differential calculus. Okay, so if we want to find things like maximum height, time for that height, we're going to need some functions to model the position. So let's get some key observations. So we know that projectiles go in this parabola shape. So that means that we're going to be looking to solve the coefficients of a quadratic. So let's get a there, at squared plus a bt. And if there's an initial height, we can always add it in later. So for the simplicity of this derivation, I'm not going to include the height, but you could always just tack it on later if you know it. Okay, so what we're going to do is notice that the acceleration due to gravity is the second derivative. That means that f double prime of x is going to be equal to negative g, because it's going down. Okay, and the other observation is that the derivative of this position function is going to be the speed. So if we put f prime of 0, that's going to be our initial vertical speed. Okay, and that's simply going to be v sine of theta, assuming you're throwing it at some angle. Okay, so how can we work with this? Okay, so I see a double derivative here. So let's just do that. Let's differentiate twice. 2at plus b is our first derivative. And then after that, we're just going to end up with 2a. Okay, so if our second derivative is 2a, it has to be equal to negative g. Let's just set them equal to each other. So 2a is equal to negative g, implying that a is equal to negative 1/2 g. Okay, now for this one, we can just bring this guy over here. If f prime of 0 has to be equal to this, let's plug that right in. So 2a times 0 plus b must be equal to v sine theta. Okay, well, there's a 0 here, so it obviously cancels. And we get that v is equal to v sine theta. Okay, and now that we have our position function, ready to find some key features. Okay, we're going to begin with the vertex. Let's write out what we got in the previous section. We got that f of t is equal to negative 1/2 g t squared plus, this in parentheses, v sine theta times t. Okay, and what I mean by the vertex is, if, just say you got this motion here, you want to find the maximum height or how long it took to get there. Okay, so what I mean by use the vertex formula from algebra, I mean negative b over 2a for the x coordinate, which would be the time here, and then plugging it in for the height. Okay, so negative b over 2a is going to be pretty simple here. It's just going to be negative b sine theta. Okay, and you have 2 times a is negative 1/2, so it's just negative g. Cancel out the negatives, and this is your time, v sine theta divided by g. Okay, and for the height, we're going to have to plug that in. So let's do that. We're going to get negative 1/2 g of this expression squared. I'm just going to square beforehand, so we get b squared sine squared theta divided by g squared plus v sine theta times v sine theta again divided by g. And what's going to happen here is that a g cancels here, g cancels, so we have negative v sine theta divided by g plus v squared sine squared theta divided by g as well. And since we have a half here and a whole, this is just going to end up with 1/2. Okay, so it's going to be v sine squared of theta divided by 2g, since this is 1/2. Okay, and that's our maximum height. Okay, now for the time taken to fall. Okay, so we're going to use the fact that a sum of quadratic roots is always equal to negative b over a. And why does that matter here? Because in projectile motion, this is just 0. And if we happen to know the other root, just call it r, then 0 plus r is equal to negative b over a. And then from there, then r is simply equal to negative b over a. No quadratic formula necessary. Find the total time taken to fall. Maybe this. We're just going to do negative b over a on our equation. So b is v sine theta. Make it negative. And divide by a, which is negative 1/2 g. Cancel the negatives and flip this 1/2. And you're going to be left with 2v sine theta divided by g. And that is our total time taken to fall. I hope you enjoyed this video.